All right, Oakley dokley. Here we are. This is something I'm going to try to do periodically throughout the class. Um, I know that most, if not all of you, have had some exposure to R last semester in Stat 503, and I mean, the focus of this class is not software. The focus of 512 is the underlying concepts of multiple linear regression slash linear models, something we'll talk more about down the road. Um, and so, right, that broad idea transcends software. But to be able to talk about these abstract ideas, we need examples. The examples need data. The data need some software to manipulate them. And so throughout the lecture, I've been focusing on SAS, but of course, you could just as easily do all of the analyses in many other software packages, one of which is R. And since you have had exposure to R, I thought it might be worth kind of going over some of the different things that we've talked about and seeing how we might do them in R. Some of the stuff you may have had exposure to in 503, so never hurts to have reinforcement, and hopefully some of it at least is going to be new. So let me say right up front, I'm bad at this, right? And I'm not going to let that stop me. And it definitely shouldn't stop you. The only way that you and I are going to get better is if we take the time to do this together, right? So I'm putting in my time right now. You're putting in your time by listening. I would also encourage you to put in your time by maybe going back to some old homework assignments, going back to some old labs, and seeing if you can do those in R, and then maybe compare your answers to what you got when you did it in SAS, right? Doing it's kind of your own way of becoming kind of professionally bilingual. All right, we're only going to get better through practice. When we're beginners, it feels clunky, it feels awkward, it feels painful. But we have to sort of push past that, okay? Personally, I do love R. In fact, as a graduate student, I probably used R more than I used SAS. But as a graduate student, I used it primarily for simulations. So that means I'd kind of create my own data and kind of look at it, look at different properties of it and different properties of test techniques, that kind of thing. In terms of data analysis, I've always used SAS. So I guess I'm a little bit bilingual, but like only in certain contexts. So I know R well in terms of doing simulations. And I love using it for simulations, but I've really never used R for doing a data analysis. So that's kind of new to me. On the flip side, right, I love using SAS for data analysis, but I find SAS really painful when I'm trying to do simulations. Again, I don't think it's like a right or a wrong or a good or a bad. I think most people think the software package that's best or the software package that's easiest is whichever one that they learned on, right? That seems pretty straightforward and natural to me. For those of us that want to do well in the workplace, that want to open up as many possible doors as we move into our professional future, I would encourage us to try to put the time in to learn both reasonably well. Plenty of jobs looking for SAS programmers and people proficient in SAS. Plenty of jobs looking for people proficient in R. So since I'm used to generating my own data, simulating my own data in R, I actually didn't have much experience in like importing data. So I did some searching online. This was a link that I found to be pretty useful. I bookmarked it. You may or may not want to bookmark it yourself. We'll see in the next few slides. I kind of extract maybe some of the key points. All right, so here we are. Right? If we want to read a text file into R, a text file data set, then we can use the read.table function. And the syntax there is pretty straightforward. CSV, right? In Stat 511, I know you got some proficiency in kind of what's a text file, what's a CSV. So again, syntax pretty straightforward. Also the read table function. If you want to read in an Excel file, you have to install a package called XL Connect. So I'm sure in Stat 503 you got kind of familiar with packages and libraries. And then we use that. We can use the read worksheet from file. So of course, Excel worksheets have a certain number of sheets. Most of them, at least that I've seen, most basic ones just have one sheet. But an Excel file could have multiple sheets. So you do have to specify which sheet it is that you want to import. And then look at this. That's pretty cool, right? Like R is not going to discriminate. If you want to bring a SAS data set into R, no problem at all, right? You can mix and match. So all we need to do is install a package. It's the SAS7b.dat package, and there's the syntax right there. I elaborate on this, I think, in a slide or two coming up, but one thing I've noticed is actually true in SAS as well. It's not just like a quirk of R. I guess really, I think it's a quirk of Microsoft. I think Microsoft like formats like quotation marks and maybe apostrophes in a way that makes them more readable, I guess. That might be the goal of Microsoft. But then what happens is if you try to copy and paste something from Microsoft into R, or copy and paste something from Microsoft into SAS, it sort of preserves like the kind of the changes that Microsoft made to the quotation marks, and then now R and SAS won't recognize them. So often quotation marks come into play when you're specifying a data set. It's true in SAS, it's true in R. So just to warn you, if you were to like take my code here from this PowerPoint and paste it into R, you might get an error. If that was the case, what I would suggest you do first is delete the quotation marks and then retype the quotation marks. Sometimes that works. I don't know. Pro tip seems like I don't know. Seems like a bit much. Maybe a noob tip. I don't know. I'm not sure that I'm qualified to be giving pro tips, but I am qualified to give noob tips. So noob tip number one. Oh, there it is. Like I already said, right? The Microsoft Word and PowerPoint, Microsoft products have they kind of format these quotation marks in ways that R doesn't always recognize. Second one, man, this one was tough. Like I said, I kind of grew up on R. So I guess years ago, however many years ago that was, 10, 15 years ago, I guess I was comfortable with the case sensitivity of R, but I guess 10 years of focusing on SAS here at Westchester, I guess I kind of got used to like not having to worry about whether something was uppercase or lowercase, and man, that was causing me a lot of trouble when I was doing my R code. So, right, be careful. R is case sensitive, right? Case sensitive means that the word B-E-A-R-S, right, our beloved bears, with an uppercase B is a different thing than bears with a lowercase b. R sees that as two different say data sets or different variables, whatever it is, and SAS would see it as the same thing, right? Because SAS is case insensitive. All right, so that's how we read a data set in, right? In SAS, right, we read a data set in, and then we kind of, what do, right? The great Professor Rieger, maybe in Stat 511, told us we should always kind of look at the data set, make sure that we imported it correctly, make sure we read it in correctly. In SAS, we might use something like proc print, something like proc contents. In R, there's a lot of different things we can do, but one thing we can do is we can do the ls command. So the ls command with parentheses, just open and closed. will show us all the data sets that are currently imported into our workspace. If we want to drill down to a specific data set, then we could put the name of that data set inside the ls function. And that'll tell us all the variables associated with it. Now, if we want to actually manipulate or look at variables, we can do that with the $sign. All right, so it's a little bit of like a hierarchy system. We have the data set name, $sign, variable name. And then we can apply functions, right, to these isolated variables. So, for example, if we wanted the sample mean of some variable, v1, then we could just type the mean function. We type mean, the mean of data set name, the name of the data set, v1. So that would be, say, find me the sample mean of variable 1 from the data set name. Easy enough. That'd be analogous to like running proc means in SAS. That'd be right analogous to proc means. Data equals data set name. Var equals v1. Run. Okay, so that's how we can kind of do like simple descriptive statistics, isolate variables. Now that we know how to isolate variables, we could look at things like correlation between variables. So we could do correlation with the core function, C-O-R-R, or sorry, I think it's C-O-R-R in SAS, just C-O-R in R. Ironic that R has less R's. It's an enjoyable observation. If we want to find the correlation between two variables x and y in a particular data set, we just do core dataset $x, dataset $y. Just like in SAS, we can actually get the correlation for all possible pairs of numerical variables by just doing core and just naming our data set. And then we'll look at all the numerical variables in there and look at all the possible pairwise correlations. If you want p-values and or confidence intervals, then we need to go a little bit deeper than the core function. There's something called a core.test function. Now remember, I'll have to try to do this in a future lecture. I don't believe I did it in this lecture at all. But you can get help in any R function very easily. Just like SAS, it has a very sort of standardized presentation of help files. And if you want help on a particular function, you just put a question mark in front of it. So if you put question mark cor.test and hit enter, then what'll happen is in your R program, like a help window will come up and it will kind of tell you about the different bells and whistles for the core.test function, including like what its inputs are and so forth. All right, so that's the correlation. Simple linear regression. We use the LM function, LM for linear model. Just like SAS, we put the Y variable on the left, we put the X variable on the right. SAS, we separate them with an equal sign. In R, we separate them with a tilde. And that will output to our screen, I think actually just the slope and intercept. Just the slope and the y-intercept. If we want to preserve information about this model, we could save it in a structure by assigning it to some name, say output. This is a little bit maybe analogous to like the to assigning stuff to like an output data set in SAS, right? SAS has the output out equals function. Here we're kind of doing something similar. We say output is equal to, and then we call that linear model command. It will run that linear model command and output all of its information into this output structure, which we can then kind of analyze that output structure or pry out from it additional details. There's lots of information sort of embedded into it. You can get a broad overview of that information by using the summary function. So once we've created this output structure, we can then apply to it the summary function. And all this stuff, we'll see in a few slides. I'll have some examples where we kind of see what it looks like. I also, for all the code I wrote down, I saved my code in a text file. I'll post that on D2L. So again, we learn by doing. So I would encourage you to actually, take my code and kind of run it yourself on R and kind of see how these different things work. We can make scatter plots with the plot statement. X variable first, then the Y variable. And you can overlay a regression line on top of a scatter plot with the abline command. Now you need to first run the LM command, right? So here I'm applying the abline to an output structure. That output structure was created in a previous slide, using that LM command. And we can very easily extend this LM function to accommodate multiple variables. So kind of moving into kind of what we've talked about weeks 3 and weeks 4. We can put any number of variables to the right-hand side of the Y variable. Okay. Notice I changed the syntax a little bit, maybe a little less clunky the way I did it there. So there I just did Y tilde X1, X2, X3. Notice we have to put pluses between them. In SAS, we just put spaces between them. And then I could do data equals dataset name. So that's like a little less cumbersome, isn't it? There's lots of different syntaxes in R, just like there is in SAS. Now, note the summary statement reports type 3 p-values when it will show that the output for that LM will show p-values for X1, X2, X3, and those are the type 3 p-values that we talked about in week 4. All right, so here we are. So first things first, I install my SAS 7bdat package. Why that one? Because, oh, look at that. Ah, there they are. Nothing puts a smile on my face like seeing those 99 beloved bears, right? I got 99 problems, but a bear sure ain't one. And so, right, there's all the different things. The install it, the library, read it in. Whew, pardon me. Where's my water? Getting too excited. All right. And then the ls function shows that the only data set in my workspace is the bears data set. If I've been running this for days, if it was like a hard day's analysis, hard day analyzing data, I might have more than one data set in there. Okay, so here I kind of did a few more things. What did I do next? I did ls bears, and that showed me all the variables in the bear data set. Right, we're familiar with this data set. There's age and chest, ID, length, name. The fact that there's names is, of course, my favorite property of the data set. Do you know the names of any of the bears? Man, why am I blanking? I think Waldo might be one. I think one of the bears is called Flash. How cool is that? I wonder how many of those bears are superheroes. I could look at the sample mean weight of all bears using the mean function. Oh dear, I can't get this cough to go away. Oh, it's dangerous to cough in this day and age. I assure you I'm fine. So there's the mean function, bears weight. Now notice another way to kind of not have to type the name of the data set over and over and over and over again is the attach function. Also, right, there's the hashtag. Hashtag is how we do comments in R. So the hashtag is just a commenting statement, analogous to the asterisk in SAS. So if I type in attach bears, now I could just type mean weight. I don't have, and SAS knows that I'm referring to the dataset bears. Okay, pretty cool, right? Convenience. That's a quality of life issue. All right, so that kind of shows us a little bit about descriptive statistics. Imagine that now we want to explore, say, the relationship between Y, a bear's weight, and X, the girthiness of its neck. Right? How would we start? We know we would start with a scatter plot. We could get a scatter plot with the plot statement. Right? We look here, very familiar looking scatter plot. Looks like a pretty strong positive linear relationship. How strong? Well, we would have to look at the correlation to measure how strong. When I say a linear relationship, what is the line that sort of best fits or best summarizes this relationship? Well, I'd have to fit a regression line. We'll do both of those things, correlation and regression lines, in just a slide or two. We also see that funneling that we saw before, and we see perhaps a little bit of curvature. So there's our LM. So there I go ahead and fit the regression model. Looks like my correlation got cut off. I did do correlation, but that's fine. I know you could do the correlation yourself. It would just be COR, parenthesis, weight, comma, net, parentheses. So that's very good, right? It leaves a little something for you to kind of fill in the blank. So maybe I leave that little part for you. But notice when I do the linear model function, all it does is just give me the y-intercept and the slope. If I want more than that, then I can output all of the information and apply the summary function. And now what do I have, right? Now I have that sort of coefficient statement. I have the y-intercept and the slope, but I also have the standard errors, the test statistics, and the p-values. And then I have a few other things. Looks like I got some information from the ANOVA table. Just the really just the F statistic from the ANOVA table. Its degrees of freedom and its p-value. I also have the R squared. So the R squared is 0.8938. So actually I know from that the correlation is what? The correlation is the positive square root of 0.8938. Why the positive square root? Exactly, because the slope is positive, right? Correlation and slope will always have the same sign. Here's the abline function. Although keep in mind, if you closed out your previous plot window, you'll have to rerun it before the abline function will work. So the abline function only works if there already is a previously existing plot open. And then it just plots that line over the existing plot. Yep, and then finally, an example of a multiple linear regression. And notice again, you could do things in one step, right? So rather than like doing output equals LM blah 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 summary output, look at what I do here. I can apply the summary statement directly to the LM statement. That's one of the kind of cool things about R, is you could do like functions inside of functions inside of functions. Sometimes it's easier to see what's going on if you do it as 3 or 4 or 5 different steps. But sometimes it's more efficient to just do it as like one big super step. And so you could take that. These are the variables we used in our week 4 lecture, so you can compare them. You should see that all the test statistics are the same as they were from SAS. All of the p-values are the same, exact same as they were from SAS. So you can see, right, pull it up, that R and SAS are doing the same thing. We just have to know the syntax to ask it to do it for us. All right. So I think that wraps everything up for us. That's our first R lecture. I'll do a couple more. If you got any feedback for kind of how it went, things that you maybe would have liked seeing, that I maybe forgot to include or overlooked, feel free to let me know. And hopefully this was useful to you. Bye for now.